I'm Colin. I work for a blockchain company in New York called Kadena. I'm wearing the shirt. All of our devs at our company use Haskell. We use Haskell for all of our products. Today, I am here to talk to you about some of the lessons that we've learned using Haskell in production for everything. There's two parts to the talk. The first part is there's kind of a descriptive half and then a prescriptive half. The descriptive half being, here are the choices that we made. Because when you're starting a new Haskell project, you kind of have to make certain decisions up front. How are we going to be doing testing? What do we think philosophically about errors? Like what streaming library are we using, et cetera, et cetera. You kind of have to make these choices from the get-go and then just go with them, build tools, et cetera, et cetera. The second part of the talk is a more prescriptive, which is talking about sort of what ought we be doing. It talks about the trinity of beauty, correctness, and good technique in code, and how those might all be the same thing, or sort of vitally linked. And I think that Haskell is a great tool for achieving those things. The target audience, I would say, of the talk are working Haskellers and people who are sort of familiar with it and the ecosystem. If you're brand new to Haskell, or if it's like something that you used 3 years ago to do Hello World, that's totally fine. I will just give you a warning up front that it's not that I'm going to be talking about anything difficult per se. I will be bringing up a lot of sort of contextual stuff, like particular libraries, and I may mention solutions to problems that you didn't know existed. So that's not anything against you personally. That's just that is what we're going to be doing today. So I already mentioned myself a little bit. I live in Canada, but the company's in New York. They've graciously allowed me to do remote work, which I think we found works decently well. I work on the Chainweb project. Our three biggest projects are Scalable BFT, which is a private blockchain, Pact, the smart contract language, where smart contract language is just marketing speak for programming. It's a programming language. And Chainweb, which is our public blockchain. All three of those things are being used in the world today. The bits of all of those things are probably flying through you right now, because radio waves. Our public Chainweb is in the V1 of its testnet right now, and the mainnet will be released in the fall. This is not particularly a blockchain talk. I'm going to be mentioning sort of all of these things in the context of having written a blockchain, but I'm not going to be inundating you with the details of proof of whatever. So I've been writing Haskell for quite a while. I used to work in Scala for a few years, and then came back to Haskell. It gives me quite a lot of joy to be working in it. And this presentation is not a PowerPoint. It's using the Patat program by Jasper van der Jagt, who, and this is a Haskell program as well. The presentation itself is just an org mode file that I've written in Emacs, and I have right here that I'm staring at. My notes are just comments. And I think it works decently well. Hopefully you agree. OK. Then let's get into it. Yeah, I mentioned the two main sections of the talk. So it's descriptive. What are we doing? So why did we choose Haskell? What do we do? Sort of what tools do we use? How do we get fast feedback? Haskell has this reputation of being slow for compilers. Well, lots of compilers are slow. But it's like, what do we do to be effective in that environment when we're using it all day, every day, so that we don't go insane? It's far from insane. It's actually quite nice. What sort of design choices did we make? I sort of mentioned those decisions that you have to make up front. And then how the heck do we deploy these things? I am bringing this up because there was a day when there were 10 Haskell jobs in the world, and there was a day in the past where there were 100 Haskell jobs in the world. It's my guess that we're somewhere in the magnitude of there are thousands of human beings being paid to write Haskell right now. That's my guess. Do we need to be, on the tier of, say, Java or Python, where there's probably millions? Maybe not. But we are a growing ecosystem, and there are going to be growing pains. And if we haven't sort of yet, as a commercial industry, agreed upon best practices, well, then I think things like this session, are great for sort of swapping knowledge. And LambdaConf itself is also great for this. Sort of telling you, letting you know things that You just weren't aware even existed. Then the second half is what should we be doing? I talked about those three things. I have some laws and principles that I want to explain, sort of things that I take as core fundamental axioms while I'm coding. And then introduce, I have a number of them. I have an extra section as well, depending on how much time we have, but show you some idioms, libraries, and functions that you may not have heard of that can help you turn that, that 10-liner into a 5-liner, or that 5-liner into a 1-liner, etc. Okay, choosing our software stack. So we had 3 bodies of requirements when we chose Haskell. I mentioned that everyone at the company are Haskell developers. That actually includes the 2 founders. They were Haskellers who met at JP Morgan prior to starting Kadena. So we had, 3 basic projects in mind. 2 of them are blockchains and 1 is a smart contract language. Blockchains are essentially web servers, but they also have to be, they have to have efficient computing. The language has to have certain performance requirements. So our 3 bodies of requirements, keeping those things in mind, were, okay, we've got some technical questions. Is there a language out there that lets us write some web servers that aren't going to be that aren't just going to be crashing all the time with mysterious undefined errors? Can we use that language to write new languages easily? Let me back up for a second. The first point is like, okay, well, we could have chosen Go or something really similar. Probably would have been fine. Can we use this language to write new languages easily? Okay, well, anyone who saw Aaron Sue's talk yesterday might know that Racket or Scheme are actually, it's a great language for writing new languages. So that was a possibility. And can we reuse backend code on the front end, say for a web REPL? And actually, we have a web REPL for the Pact smart contract language, which you can see right there. Okay, so those are our technical questions. But it's not just that. We can't just ponder about these things all day because we have money to spend and money to save. So is the code going to be correct? Is this language going to, regardless of what it can do technically or what people have managed to do somewhere, because if you put enough, you could build an arc, and if it had tons of holes, but you had enough people, you could just continuously be patching it all you wanted. You could do that with essentially any language. Is the code going to be right by virtue of it being a good tool? There are such things as good tools and bad tools, and people might tell you that that's not true, but I think it is. Some tools are better than others. How can we tell which are better than others? I found a good metric is how much pain do they cause you? Because it's hard to ignore pain, I think. And how much are we going to have to reinvent the wheel? Okay, it's great to be, and like this might be referred to as, the novelty budget or whatever. You could start a new project and you're like, all right, I'm gonna put Pokemon cards in the blockchain or whatever, right? And you're gonna use language X for that. Well, it turns out there's like 5 people in the world who know how to use language X, but now you're number 6, and you're gonna, kill the world with this. But great, you're gonna have to reinvent essentially the whole ecosystem yourself. And then we had human questions. What language and its tools and ecosystems are going to fulfill our developers? Because you can write anything in any language, essentially. As long as it's Turing complete, you can do anything with any language. But, like I just mentioned, not all tools are created equal, I think. Some are going to bring you more pain or joy than others. So for us, Haskell was the obvious answer to all of these requirements. Of course, Haskell has room for improvement. It's certainly not the last programming language that humanity is going to use. But everything considered, I have a bias, obviously, but I think it's one of the best languages that we have right now. So what's our dev environment look like? Okay, so here's me just sort of explaining how, our layout. This is like the start of the choices that we made from the get-go. Okay, so Chainweb in particular, the main project that I work on, we use a .cabal. What's that a choice against? Well, a package.yaml from HPAC. I used to use HPAC on all of my projects. I recently switched them all back to Cabal, which I'll explain why in a second here. We have a default.nix committed to the repo for our CI deployment. That will become relevant soon. And then the people who wish to use Stack, that's me, and a few others, or just a cabal.project file, sort of maintain them on their own. And we've found that it basically is not a lot of effort at all to maintain sort of separate dev environments for everyone. The source of truth, though, we do have a source of truth, is the default.nix. So you can do whatever you want with your build tools, but if it does not, like say if you've bumped a like you've bumped a dep, like you've pinned an extra dep in your stack.yaml, and everything's compiling for you, but you fire it up on CI and it fails. Well, that's on you to then go and fix the source of truth, the default.nix. And I mean, we found that that's not actually that much effort to do that, and can speed up development for people who are used to one particular way. So in particular, in our .cabal, we enforce at least Cabal 2.2. When you like stack.new a project or Cabal, I'm sure Cabal has a similar one, oftentimes it will default to like 1.20 something, which is quite old by now. Even 2.0 Cabal is a few years old by now, I think. So why do I enforce 2.2? Because it gives you the common stanza. This is new. This is why I think the package.yaml format is no longer necessary. This basically gives you everything that you could have had. Experimentally, I like to do this. I like to, put my money where my mouth is with these sorts of sort of theoretical claims. I took all my open source projects, switched them from package YAMLs back to Cabals, and the PRs were essentially equal. Like the lines removed to gained were essentially equal, and Cabal is sort of the original format anyway. So we turn on these warning flags. I don't think these are particularly controversial. Does anyone want me to explain why we chose any of those? Shout out if you're curious.
Question about incomplete record update.
Sure.
You can't update a record unless you update every field in it?
No, that's and incomplete record updates, now that I look at it, might be irrelevant now that partial fields is in there, but the idea being that if you have a sum of products and the products have field names that aren't the same across the various like sum constructors. So say you've got like, cat, and he's got a field name / dog hobby. And then you pull and say that's like a pet data type. You pull in a pet into your function and you just say like, p, and you use record update syntax and you just say like, name equals whatever. That's only true. That's only not like a degenerate case if it were a cat to begin with. So incomplete record updates would catch you there. Partial fields will actually tell you that, hey man, you can't even name your things differently. If you're going to have sums of products, you can't name the fields different things. Identities is interesting. This one is, I think, not very well known. And it's unfortunate that you have to add extra ones. Wall, you would think, would just give you everything. Unfortunately, Wall doesn't. You have to go to the GHC user docs and see what it excludes. And these are kind of the ones that it excludes that matter, I would argue. Identities will tell you if typically, the main case for it is if you are doing a numeric conversion that doesn't matter. So sometimes requirements can change, like the types in your function signature can change. You were going from like, it was taking in an int, and then you were like casting it to a word using from integral like inside of your function, but then requirements changed and the input to the function just became word. You wouldn't get told that was anything wrong with that because the from integral would just be casting word to word and it would be like a no-op and wouldn't warn you. So identities will catch that. It'll be like, hey, that's a redundant cast.
Yeah. Won't the specializer make that a no-op anyway then?
It could. Anything else? Error just makes warnings turns into errors, and compat is just for future compat, where they kind of warn you about flags that exist but aren't in wall but will be in the future. So it's kind of nice to have those three in combination. It's like for future proofing. So in our .cabal, we have a distinct library and executable sections. The bulk of the project basically lives in a library called Chainweb, that there is then an executable section later on that essentially imports it all, has a little bit of song and dance regarding pulling in information from the environment, getting some CLI flags, and then just sort of calls out into the main language of the library. Why would you want to do that? It's because you can't test executables, or rather you can't import executables. If you have a test suite section in your .cabal, you can't say like it requires Chainweb as one of its build dependencies, and then call the modules in, unless you had done that splitting up. That does sound kind of dumb, but it's it can actually keep things clean if you have the separate sections. That way, if ever another project had to rely on, say, Chainweb as a library, which you might not have intended, but maybe there's a legitimate use case for, which we do actually have in some side tools, then you get the bonus of you can just trivially sort of hand like that library around and use it. If we have extra tool binaries, we merge them all into one. So essentially, there's one extra binary that we have called CW tool. We used to have a plethora of tools. Now we have one called CW tool that has the modules of all the sort of the former separate tools all put into one, and you differentiate on which one you want depending, or with the CLI flag. So if you want to use the transaction generator for sending like auto-generated transactions off to our test network, it's just CW tool space TXG and then the options that the TXG wants. Why is that good? Because it reduces compile time, because it doesn't have to do as much linking. The overall binary size is smaller, because like if you had 5 binaries that all had like copies of what like lens or whatever in it, that's obviously going to be bigger than if you had done it once. Horror story from a colleague who said that at their previous job they had so many separate tools that weren't merged that like every compile you did, it would produce like gigs of extra stuff. Not necessary, especially when we're pushing this all up to caches after CI, like as part of deployment. You want that small. Okay, so how do we write Haskell? I did a little poll and was surprised that basically everybody except for one developer uses some variation of Emacs. It's either Emacs or Spacemacs. I used to be, for years I wrote with vanilla Emacs. I now use Spacemacs, and I think it's just a better default. The settings it gives you out of the box are just better than anything I could have written. And our main feedback mechanism, this is important, is GHCID. If you haven't heard of GHCID, I highly, 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 highly recommend it. Here's how I write Haskell. I have 2 windows open on my computer thing. One is Spacemacs. The other is a terminal. I forgot the word. The other is a terminal. I navigate to the project. I type in GHCID. What does it do? It's like GHCI, but it detects file changes, and it doesn't compile. It uses sort of behind the hood, there's this secret option called F no code, which will do all type checking, but it won't actually compile anything past that. The effect of this is that you get extremely rapid feedback for your type errors. So you can kind of take type-driven development to the extreme where you can start inserting holes into your code everywhere, and basically the compiler will just tell you what to put in there because you're just sort of, you put in some holes, you save, it says, oh, hey, you probably meant this type, and oh, by the way, this function satisfies this type, and like it's the only thing that you have imported, and it's the only thing that makes sense, so you just sort of put it all in there. I've been using Haskell since 2011, like basically back since like it was basically just Cabal build every time you wanted to see if there was like any change.
So you said you're using Stack as well?
I personally use Stack.
So why not using Intero?
Why use what?
Intero?
I used to use Intero. I no longer do. I think Intero is great. I no longer do because I found that I don't need it. If I turned off Intero, I lose squigglies from flycheck. But I switched it to GHCI recently. It basically just gives me syntax highlighting, and occasionally some auto-completion. Actually, most of the time some auto-completion. But GHCID basically obviates the need for any other surrounding tooling I have found.
Would you be willing to do like later on like hallway sessions?
Sure, sure. Also, opening buffers the first time when you have intro, it has to compile it. So I found that the snappiness of opening each buffer for each new file, there's like a little bit of a delay there. Yeah, so we have one guy who uses NeoVim. Everyone else is on some sort of Emacs. I don't know what that is, but and it's not even like Emacs has like special Haskell support or anything, although the Haskell layer for Spacemacs is quite good. Okay, design choices. Here's the main tree of choices that we made. Okay. You may know that using alternate preludes is kind of this cool hip thing that you do. Oh, base is lame. No one wants to use prelude. Oh, head's in there. That's not even a total function. Only nerds would use that. So then you switch to like something, or everybody has basically invented their own alternate prelude. You've got relude and then you have re-relude. That one kind of makes me laugh a little bit. Actually, I quite enjoy base prelude because it basically just gives you, I'll talk about that later, it gives you everything that you would have wanted that was in prelude anyway that you wouldn't have imported qualified. So you just sort of have all these symbols that you natively would have wanted. In particular for Chainweb, we do not use a alternate prelude. For testing, it's tasty, which is nice and terse. All your tests are basically in I/O, so you can be doing arbitrary I/O in there. Do your tests. You can have multiple sort of assertions in one test case. It's quite nice. For using quick check, obviously for property checking. I know there's like gauge and some other things or alternate options there, but quick check is just the beast that everyone uses. So do we. For streaming, we use the streaming library. Your options there were essentially pipes, conduit, machines, and streaming, and also Streamly. Streamly is kind of cute, but I don't know if, how much, the bus factor on that one kind of worries me, whereas streaming seems to have at least a decent amount of humans behind it, and it's quite easy to use. If you know how to use lists and compose list functions, you know how to use streaming. We chose it because at the time, Lars and I both knew it the best and liked it the best. And it was the quickest thing to just grab and use for what we wanted. Yeah. Lenses. So we have a particular thing about lenses. It's Kadena policy that not to use lens operators. I will not mention names. That is his Twitter handle, yes. So I mean, we use lenses pretty liberally. Obviously, we don't go totally crazy, but because that can incur certain costs. But we use them where it's appropriate, and typically we use the named variants of the operators instead of the operators themselves. For CLI flags, you'd think that opt-parse applicative would have been there. It's not in this case. We use configuration tools, which Lars wrote. Lars Kutz he's written a number of libraries in Haskell. He works for Kadena as well. What's interesting about this is while it's compatible with opt-parse applicative and basically gives you everything that it does, you might know that when you have opt-parse applicative, it automatically gives you like a help option, even if you didn't define it yourself. What's interesting about configuration tools is that, yes, it gives you help, but it also gives you a print config function, or a flag. What that does is it will say, OK, whatever flags you've given it, if you just like help, if you use print config, it won't do anything. It's like a dry run. It'll print out a YAML form of your configuration options, just like in YAML, right to standard out. You can then copy that, put that into a file, and then use the sister flag config file. So this is really good for configuring your programs where just running it isn't really the default thing that you would ever want to be using for a real situation. So for a sufficiently complicated application, you could have many, many, many flags. You don't want to be typing those in. If you use like fish as your shell, maybe it just saves it all for you, and that's fine. But for like the bashy people, that's not going to work. So all you have to do is basically figure out your options once, use print config at the end. It pipes out the YAML that you want. You copy the YAML to a file, and then your invocation of the program, and this is how Chainweb is actually invoked on our servers, is Chainweb node, config file, and then the path of the config file. And you get that for free. The data type of your environment, like the thing that you're actually like reading into with your config files, or your config options, has to have JSON instances. That's how it gets the YAML back out. And logging, we use yet another logger, which was also Lars. So we found that we didn't have to do anything fancy for our effect system. Lars and I were talking a few weeks ago, and he like sort of chuckled. He says, wait a minute. I think this is the first Haskell program that I've written, or like big Haskell application, where I didn't write a monad. And it's true. We use I/O. If there's errors, we throw, and we catch. That's just sort of the world if you live in I/O. We aren't pure script. We don't get to just throw and catch in I/O in insane ways.
Why did you make that decision?
To not write one? Well, we basically don't need one. We don't need one. Like we don't need any sort of more fancy effect stack. A blockchain basically doesn't need one. Here's what you do: you get things from the environment, like your options. You provision a bunch of things, and then it's mostly just a concurrent application. You go spit off your miner, you go spit off your peer listener, you go spit off your mempool, and you go spit off like your packed service. These are all completely separate things, basically just running in like forever sort of I/O loops. They're not communicating. Well, they are communicating, but they do with tvars. You don't need like a state T or anything for that. That doesn't make sense. And at least since last year was kind of one of the hot topics was like, oh yeah, like what do you think about accept T? Should you have two error channels, one through the accept T, one through the I/O? And we basically decided no, that's just not, no. Like errors, if you're in I/O, things will throw, and you got to catch. There's just no way around it. You can't pretend that there won't be errors. There was a question?
Yeah, could you give a quick definition of Rio for people that don't speak Haskell natively?
Rio?
Yeah. One comes slide. All right.
Oh, Rio, sure. Rio is basically one chain of thought is that the only interesting effects stack is having some sort of reader and then I/O. Then Rio is essentially that. It's a new type wrapper around reader TIO, and then it has some helper functions that let you sort of use that more natively. It's from the package Rio. And it basically says, yeah, if you have errors, throw them in I/O. If you wanted some sort of like local state on a function or something like that, just I guess do that locally, but like at the application level. And Rio is essentially optimized for CI applications. I haven't yet used it in like a web server or anything, but I'm porting one of my own projects to use it. So far, it's going fine. Like it's used in Stack, and I have a similar project that's just a command line application. It doesn't need like a hardcore effect stack. And I'm saying that as a guy who went from like total manual passing around your environment variable manually in I/O. Then I learned what transformers were, wrote transformers, learned that was stupid, then switched to extensible effects, then switched to simple, free or simple, then switched to fused effects. Now I'm switching to Rio. So I'm kind of, it's my sort of mad science lab. Did that long-winded answer you?
Thank you.
Okay. What do we auto-generate? So we auto-generate our templates, or our lenses with template Haskell, which is a fairly non-controversial thing to do. If you have a bazillion data types and they all have, you know, the underscore in front of them, that can actually slow you down because it's template Haskell. It also can have adverse effects with GHCID every once in a while because it can't just type check everything quickly. It has to regen the template Haskell to know if it can even type check. So that can slow things down every once in a while. But we handwrite all of our ASIN instances. Why do we do that? So I hate boilerplate, but at least in this case, my opinion doesn't matter. This is mostly sort of from inspired by like war stories, in that if you auto-generate your ASON instances, so you know, it's got your data type, deriving, generic, to JSON from JSON. If you do that and the ASON library changes underneath you, and you had persisted some JSON stuff on disk, and you needed to be reading it, you can get in trouble. And that has happened in production, not to us, but it has happened in production where ASON changed underneath, and it forced, what were they? They were stuck on like some ancient version of GHCI for like 2 years, or GHC, for like 2 years because they couldn't, it was just like too much burden to figure out that thing. And they had giant amounts of JSON data that they had used like older versions of ASON to persist. So, even though it is boilerplate, all of our ASIN instances are handwritten. I shed a tear every time I scroll past them. How's our app configured? I explained that already with configuration tools. Have a whole bunch of options, use print config, get your YAML, pipe that back in. It's also easier to change things on the fly. Like if you want to run something and it doesn't go quite right, you can just go into your YAML file, twiddle the one thing, and then just quickly run it again. You don't have to muck with like scrolling through, like, you know, when you're on your terminal and it's a super long command, you got to be like holding down the right button to get all the way to where you want to be. No, stupid. Stupid. Deployment, how do we do that? We use NixOS. Fancy. It's not a big deal. We use Terraform to provision machines on AWS. They are raw EC2 instances. We do not use containers. I think that Docker is a failure for us. It's a failure of ours to figure out how to provision environments correctly, and NixOS solves that problem. Docker is like a layer in front of, Docker is basically mostly an apology to me, I think. I don't think it's necessary in this case. What we do is you have a PR app. Our CI runs it using Nix, as I said. The result of that, if it passes, is uploaded to one of our caches. All of our machines have the proper keys to access the cache. Then all you do is to flip the version of Chainweb if you want to be testing a new version or releasing a new version. Here's what you do. You can send a batch command to all the machines currently running, like we have all the SSH keys appropriate for this. You basically say, hi Nix, see the version of Chainweb you're currently running? Use this hash instead. It says, oh, that's cool. I'll look in my local store to see if I have that. Oh, I don't have that. Where can I look? I'll look in the Nix cache that you told me about. And then it just automatically downloads the version that just passed from CI like a minute ago, pulls down all the deps it would have needed, and then gets it all. You flip a switch, it switches to the new binary, and now you're running a new version. Question in front, Beard.
When you get the cache keys onto the actual instances themselves, do you use like Terraform?
It's part of the provisioning process to have the keys up. It's in like our top level Nix config. Yeah.
What are you using for your cache?
Sorry?
What are you using for the cache?
We're working on an S3 solution, which is much faster.
Just like that we usually set it.
Yeah. Anything else?
What's your bus factor with the NextOS configuration?
2. Well, no, it's let's be generous. It's about 3, but there's only only like 5 or 6 of us working on this project. So this one in particular, and we don't use NixOps as I said there. That may change in the future. Anything else before I move on? Yeah. Yeah.
Okay, is everyone somewhat responsible for DevOps? So like you have special people basically responsible for the main responsibility?
It's a few people. Yeah. Most people have access to the machines in general, but like it's like a function of our size and just like focus as well. It's mainly a few people's concern. Okay, moving on. Great, we have half an hour left. The break is after this. So usually the session would end at about, this says I'm at 29. My phone says 33. So we might go over that 50 point. I can basically keep talking because I have extra material. If you aren't sad about getting 5 minutes of the break eaten up, then please stay and enjoy some more material. So that was the descriptive half. It's like that's what the decisions that we made. There are some more decisions that we can make, and this is more of a soapbox. That was not correct. Still not correct. We're going to move back in. Thank you for your patience. So we all want our code to be correct, but how do we expect it to get that way? Bit rot is real. It's a fascinating concept, I think. Code mysteriously gets worse over time. Doesn't it? I don't think that's a controversial statement. I think the keys to writing long-term software are 3 things which might actually be one thing. Beauty, correctness, you could also call that functionality, those are tightly related, and good technique. So what is beauty? I'm calling beauty, something made with beauty is going to invoke pride. And things made with pride are more likely to last. These are very hand-wavy things, but I can't write down a definition of beauty and everyone's gonna go, oh yeah, that's great. Like, it's this subjective human thing that we can only kind of like hint at. So I'm doing like an indirect proof of kind of like our, like indirect evidence of what beauty is. So what's correctness then? If beauty is this thing that invokes pride in you, and somehow that pride can make you work harder and then the thing lasts more. This university is beautiful, for instance. They put a lot of effort into making this university look amazing, and I love coming here every year. Like, I wish this could have been my university. What is correctness then on the other side of the spectrum? Correctness says it doesn't matter what the code looks like if it's wrong. He's got a point. But then what happens if we maximize that philosophy? If we maximize, and I'm sure we've worked with all these people, maybe we're these people. We just got to get the code out. Like, the means justify the ends. Just go. Destroy your nights and weekends so that you can just, barf out code. The only thing that matters is the code, right? Is like the sheer, number of lines, like shipping those features, right? I'm sure we've all worked with those people. We might be those people. But then we all have the experience of then debugging that thing 6 months or a year later. And then we're like, why was I so impatient 6 months ago? Why couldn't I have just taken like 5 extra minutes not to do this like garbage the way I did it? Well, it's because there's always something cool to do, and you got these requirements, and your boss is behind you being like, like our users need cat videos. Like where's that feature, right? There's a point to that, but we can't maximize that. We can't maximize beauty either, because if we do that, we're not going to get anything done. So how do we balance these things? I think the balance is good technique. Good technique is the actual action that we take to bring code into the world. Good technique is important. Why? We've all had bad food. We all know what it means to have eaten bad food and eaten good food. Chefs aren't all created equally. You have to work hard to become a good chef. And maybe you have to have good ingredients. That's probably a part of it too. And your tools are probably important too. If you work in like a crappy kitchen that's dirty, well, that might hinder your ability to produce good food. That's going to make people weep. There could be some like, cultural history or something like that, like, like precedent, like, the French cuisine, that kind of stuff. Like there could be a whole establishment for producing great stuff. I think good technique is that which maximizes the harmony between beauty and correctness. There is a sticky concept that we can talk about, which is the concept of readability. So I'm very skeptical of the concept of readability. I think there are two problems with it. It comes up all the time, of course, right? Someone can be like, oh, we should do this to improve readability. Or like your PR guy can come in and be like, this code is unreadable, right? And then you got to change it or sort of do what they say if you want your job. I'm skeptical of the concept of readability for two reasons. One, it's irrefutable. It's a completely subjective claim. I can't, if you say that my code is unreadable, I can't refute it. If you're being ungenuine, I also can't figure that out. Maybe you're a troll. You're trying to like, undo what the work I'm trying to do, maybe.
But isn't the same thing with beauty and color? Like that can be like subjective as well.
I would argue that beauty is not subjective, not entirely at least. I think we generally agree on some core of what it is.
But I can say the same thing with readability as well.
I'm still going to say that they're different, and I'll motivate for it. The other issue that I have with readability, and I'm going to contrast that with something else really quick. The other issue with readability is that there's no bottom to it. Anyone can claim it. The ultimate person that we all agree is like the ultimate Haskell wizard on the entire earth could write something that just like, makes children weep. But then like a day one beginner could come in and be like, that's unreadable. Do they have a point? Or are they just inexperienced? You have to balance that, of course. This is different, of course, from the concept of, or the idea of I can't read something, which I think is a problem of education, not of like aesthetic sense. If someone comes in and they're like, I literally don't understand what you've written, they might say it's unreadable, but what they really mean is I can't read it. Those are different, I think. So there are a few things that, I'm going to introduce a law, and this might be the most important slide of the presentation coming up. I'm going to present a law and then a principle or two that I assume to be true while I'm coding. And the claim that I'll make is that by assuming those things are true, that the code comes out better over time and the code is more long-term friendly, that it's more maintainable. You won't hate yourself 6 months from now. So here's the first one. It's called the law of God's one-liner. And I claim, for any piece of code, there exists a refactor which approaches a one-liner. Okay? Let that sink in for a sec. For any piece of code, there exists a refactor which approaches a one-liner. The law can be applied recursively. So 10 lines became 5, 5 became 3, 3 became 1. The ultimate nirvana of which is being released from your code completely. Right? I'm not kidding. What's the point of programming? The point of programming is to stop programming. It might sound crazy. You can say I'm a whack, whatever, but because what can happen is often the mechanism that lets you refactor is you've noticed some pattern. And this is related to beauty, I think. You've noticed some pattern that you're like, wait a minute, I didn't have to do this gross pattern match. I could use this combinator that I learned about this week to slap that together. And then you might have noticed then some other connection. You're like, oh, this is just this. Maybe you realized that parts of your code were connected in a way you hadn't realized. And so you're able to kind of bring things down. It's not always just a matter of applying some combinator that does the thing that you were already doing. It can be more than that, right? But usually you're noticing some pattern. And if you can get it down to that one-liner, you might actually realize that you didn't need your function at all. That someone smarter than you, probably, it was probably Ed Komet, wrote that thing before you, or somewhere else, or maybe it already exists in like your inevitably, in like the utils module that inevitably exists in your code base. You can delete your function. That's the best thing. Isn't it the best feeling in the world when you can merge a PR and it had more subtractions than additions? You've increased features. You've improved performance. Maybe the docs are even better, so you actually added extra lines, but you're still up on the subtractions. That is like, oh, I'm shaking, actually. Like, I love it when that happens. We program so that we can stop programming. There's a corollary to this law. Whoop. I pressed the very wrong button. The corollary to the law is that if you cannot find the refactor, there's a mistake in your design. Solving the mistake will unlock the refactor. There's a slightly more controversial corollary when I was talking to Aaron Sue about this. If you've applied as much effort as you can and you've learned all the things, and you think that you have like the most wisdom in finding patterns in code, and you still cannot find the one factor, chances are you're using the wrong language. Your language might be too weak to allow you to express the code that God would have written in the background. You might have heard of that famous mathematician. It's the something number. You know, like how many citations away are you from like co-writers? Yes. He had a quote which was, like he would always refer to God's proof book. Like he couldn't, well, I wouldn't say he'd know. Like he envied that like whoever's sort of behind the universe, and you can say whatever you want about religion, that whoever's behind the universe like sort of knows that like the best proofs for all the mathematical problems that we have. And what I'm saying with this is that there exists some refactor in the space of all possible code you could have written. That there's always going to be some shorter form of it that is more beautiful and like, you know, possibly more correct and like appeals better to the human sense. Now, I will preempt some rebuttals here, some like smart aleck rebuttals that say like, oh, well, I could just change all my functions to be one letter and I could just like jam all my code on a single line that's 1,000 lines long. No, that's cheating. Like that's not approaching this law in good faith. You know what I mean, I think, when I say one-liner. By one-liner, I mean the thing that when you did the refactor and it shortened down and you went, ooh, and you like felt it, right? Yeah.
Paul Rand talks about this in the form of fewer nodes in your abstract syntax tree.
That is a material way to say what I said, yeah, yeah. Completely correct, I think. What did I say? Also, this is not a comment about whether you should pursue the refactor. Just a statement that there is one, and you're going to have other requirements, right? You got code to ship. Your users need cat videos. You got to get on that, right? Maybe you can't always find it, and you shouldn't just be putting up PRs that are just refactors, right? You're like, oh man, I saw this talk, and I should just be refactoring stuff all the time. You're going to get fired if all you're doing is putting up PRs that like refactor stuff that doesn't have business value, right? So if you kind of do this stuff as you go, I think it can bring you more value long term. Here's a principle that I use when I program. I call it the principle of perfect input. Instead of writing that, so you've got some should I buy Bitcoin, it takes in a maybe some price history and then tells you what you should do. If that maybe price history represents the possible failure of having retrieved that price history from somewhere, this is bad. Do not do this. Force your caller to deal with it. If they had to get the price history from somewhere else, assume that you just get it. If they had to do that, like force them to make that decision sort of higher up. That way you don't have to deal with it. That way the concerns of like their laziness doesn't bleed into the concerns of your function. And when I say they, I could mean you because it's us, right? Or it could mean you 6 months from now. Here's another one. Instead of writing this, so you've taken in a list. Lists are everywhere in Haskell, right? They're like one of the first things that we learn to use. And we learned a pattern match. We're like, oh yeah, when we're doing recursion, we got a pattern match on like the empty thing, and we can do some thing, and then we can pull it out and we can do some recursive thing. Well, I kind of need a cat here. I want to pet it. I have no choice. Cats need attention. What if I get no cats? Well, then what do? Do I return this in maybe? Do I throw? It sort of brings all these extra concerns into your function that slow you down and make you sad. Don't do this. Let's be honest. Write this instead. This is in base, NonEmpty List. Okay? It has basically the exact same interface, except its head function is total, and you know that it will always have something in it. So you can just say, okay, NonEmpty cat. Force the concern of constructing that in the first place up the chain. Yeah.
Anything you're talking about reminds me of Bertrand Meyer and his idea of contracts. What's the caller's responsibility? What's the callee's responsibility?
Yes.
And even though you wasn't a functional guy, you might even read some of that. And it sounds like you're saying similar.
Yeah, I've kind of like sort of organically arrived at this after a number of years, and like this has to be balanced with the principle of maximum caller flexibility, or also known as like the principle of maximum caller laziness. Because it could just be that like, oh, I don't have time to worry about my types, like I gotta get stuff done in cat videos, right? And you just pass that maybe in, and you kind of like deal with it awkwardly. Maybe you got like a join or something in there, and you're forcing it down in this new function. Stop writing that code. This too. And we can take it further, actually, because there's a relatively new package called NonEmpty containers, which gives you NonEmpty set, NonEmpty map, and NonEmpty seek, and they do what you think they would. They always have stuff in them. What I found by using this, by maximizing the use of this across an entire code base, is that you basically have to deal with the possibility of emptiness in one place at the beginning. After that, you essentially get to live in this like magical land of totality where you always have stuff. The cool thing is that all of these non-empty and those 3 ones all have an instable of foldable 1, which is the exact same as foldable, except it's guaranteed to have stuff in it. You might recall that fold map and fold in the normal foldable type class has a monoid constraint there. This has semigroup. Because in your container, you might not always have monoids. It might be something that's a meaningful semigroup, but it just has no notion of emptiness. And you want it to be like a cool guy and like combine them with just like the semigroupness, but you couldn't because it was like a function or something. Now you can do this if you use a foldable 1 here. Okay, let's talk now about, so we've got 12 minutes by this. Shall I keep going? Okay, some quality of life libraries. These are things that are kind of like in the depths of Hackage that you might not have known existed, and they can help you take, this is sort of how I try to apply good technique. It's the thing that can let you turn that 3-liner into a 1-liner. And you might say, well, that doesn't matter, but less code, I think, in general, is better. Here's a claim. You can refute me if you want. Throw bottles or whatever if you want. For 2 pieces of code that appear to be functionally equivalent, the shorter one is better. Is that heresy? Absolutely. It's absolutely heresy, or it's absolutely correct. Okay. Because I mean, like the longer one, just think about it this way: the longer one has a larger surface area for bugs by virtue of it being bigger. So you should try and get small. Right, so golfing is an idea here, and I think that not golfing is part of the spirit of God's 1-liner. And that like, and also not being a smart aleck is another one. Like I think that's tied with golfing, and that you're like, ooh, look how clever I was. That's not the point. It's that you wanted to arrive at something which was like the true solution. Like had it been like, the ultimate programmer from above was doing it, like he would have written that. Or like it's what Haskell would have written, Like Haskell will fight you. Languages will fight you when you're trying to use them wrong. Yes?
Kind of a restatement of that is the more stuff you do, the more opportunity there is for things to go wrong.
And thank you. And there's a more material concern. The longer the code is, the more calories you have to spend visually parsing it. Okay, let's get into these libs. Yeah. Golfing is when you like, where you take some piece of code and you for fun, change the way it looks, either to increase the length or to shorten the length. And it essentially destroys readability. It means that no one can look at it, and it makes it extremely difficult to understand what it's doing. It's cleverness, I would say. Like you are shortening it, but you're not making it more beautiful. I mean, maybe you could like turn it into make your C code look like a swan or something. That's not the beauty I'm talking about. But
Sometimes people call that too clever by half.
yeah, sure. You can look up. I know there's a famous one like C. There's like an annual C golfing competition that they have on the internet. I remember seeing one that was like a Coke bottle or something, and it was like a runnable C program. They're absolutely silly. So I mentioned this briefly. This base prelude. So all you have to do is you put no implicit prelude as a language pragma either at the top of each module, or you just put it in your Cabal file if you feel like just spreading it across the land. You import base prelude, and that's it. You get everything you would have wanted anyway. Personally, I hate whenever I'm typing like traverse. If I type like traverse underscore, and then the compiler tells me, yo, bro, you didn't import data.foldable, I'm like, shut up, get out of my way. Let me use traverse, okay? So if you use base prelude, it has no other dependencies. It just depends on base. You get everything from data char, data word, data int, data foldable, data semigroup, and the list goes on. This one is, we don't use it in Chainweb in particular, but I have found that in apps, it will reduce maybe, because app modules can get kind of big, it will reduce 5 to 6 import lines. They'll just be gone. And they would have been there anyway. Like it's no special thing that those particular import lines were there. Like if you have to go import data.word and then in parentheses word just to get that symbol, I don't like doing that. Caveat, don't use alternate preludes in libraries. That's impolite. Same as it's impolite to import lens as a dependency in your libraries. Shouldn't do it. That's not to say you shouldn't expose lenses that you've handwritten, but relying on it is kind of rude. OK, here's another one, the errors library by Gabriel Gonzalez. So every Haskell in here has written this function in their life. OK, it's, I haven't either, but I wanted a maybe, or it like gave you some error. Maybe you got it from Servant, or you got it wherever, and you're like, I don't care, dude. I just want like maybe. I just want to know if it's like wrong. And so you opened up your utils.file, like I'm the best programmer.utils, and then you wrote this. You don't need to write that anymore because Gabriel Gonzalez has come down from above and saved us. So look, it's everything that you would have wanted. Hush is the equivalent of that. Hush quiets either. You also have hush t, which is the equivalent from except t to maybe t. Then you have note, which is kind of the, like, if you want to be fancy, hush is the natural transformation from either to maybe. Note is kind of the thing in the opposite direction, but it takes that extra input, right? Note says, I have a maybe, but like say you've got a bunch of lines and they're all like sort of like either-y lines. You're like using either as a monad. But like one of those lines was a lookup, which is like returns a maybe, right? And you're like, oh crap, that kind of cramps my style. And you got like pattern match on it, or you use like the maybe combinator to like just to unwrap it and like rewrap it in justs and, or like lefts and rights. No, stop it. Use note, which will just say, okay, if it was a just, now it's just a right. Or if it was a left, here's like the error message. So you could say like, note failed the map lookup, and then your lookup. Similarly, we have hoist maybe, which will say, hey, maybe get up there into your transformer stack. Same thing for hoist either. Then we have, okay, here's that lookup, but you're in an except t stack. So you can just go straight from the maybe right into except t in like one little thing. No gross pattern matching necessary. No having to like wield combinators to like to do that manually. Interestingly, we don't have the opposite. We don't have the thing that goes from either to maybe t. Maybe that's just an oversight. Errors by Gabriel Gonzalez. In particular, the control.errors.util module. OK. So recall these functions from base. We have map maybe, or no. So one day you've got a list, and you're like, OK, I got like a list of users, and I'm going to like look them all up in my map. And you do a map, and you do the lookups, and now you're like, oh, dude, now I have this list of like maybes. This is gross. How do I deal with this? And you're like, oh, OK, cat maybes, cool. That just gets rid of all of them. Problem solved. But then you learn, wait a minute, you're trolling the docs one day, and you're like, I can do that in one step instead. You use map maybe, and you're like, oh, wow, I'm cool. Then say there's actually an interesting use case using either as like a sort of our partitioning logic. You usually will conceptualize either as being like the bad thing and the good thing. You don't have to. That can legitimately just be a normal coproduct, right? It can be like something over here and something over there, and there's no sort of value judgment about which one is good or bad. So you can use partition eithers for that, where if you already had mapped over it and produced all those either things, you can then split it up into the lists of the two results. But notice that there's no thing that kind of does that split in one step, sort of the equivalent to map maybe. There's also another missing thing. What if we want to do that effectively? What if we're making a call, or we're doing like a database hit, or we're doing something else that can return a maybe effectively? That's why the applicative's there. So we have witherable by Kinoshita Fumiaki, which will just do what you want it to. It's map maybe, but applicative, when your action to get the maybe thing had some effect associated with it. Then there's a sort of a level up from that, which is compactable by Isaac Shapira. You have fmap either, which is the thing we wanted. It's kind of like that. It's the sibling to partition eithers. So look, you're over some functor, which can be a list or whatever. You're producing an either, and then just splits it up into two lists as part of the process of going over that. Fmap either. And then you've got traverse either, which is the either equivalent of wither. Quite handy. Prevents you from having to, compose a bunch of things together. Scheduler. OK. You've got a list. You are running an IO action over the list. And you code up your code, and you hit go. And it's taken a while, because you're like, wow, geez, this is taking quite a while. Maybe they're all web calls or something like that. And you're like, oh, man, I forgot. I've got like 10,000 users I got to look up or whatever. And it's hitting each one, because maybe you're using traverse or using mapm, which is basically the same thing. And then you're going through the docs one day, or maybe you read Simon Barlow's book, the concurrency book. And you discover map concurrently, and you're like, oh, sweet, that's just the thing I wanted. Go over all my users and just do all the web calls, or do all the database hits, or do whatever, and do it all sort of concurrently. I got stuff to do. Go drink a coffee. You hit enter, and what happens? Your laptop melts through your desk, because what it did, and I've done this, what it did was it spawns a thread for each thing in the list. If you had 10,000 things or a million things, it's trying to make like a million web calls at once. To a degree, there's obviously work stealing in there, but it will. Or pardon me, not work stealing, but scheduling. map concurrently will typically not do what you intended. There is a thing that will do what you intended. It's called traverse concurrently. It's in the scheduler library. Alexei Kulesevich is the guy behind Massif, which is the thing that sort of replaced REPA, if you're familiar with array programming in Haskell. So notice that the type signatures are basically the same, except there's this new comp thing as the first argument. Comp basically just says, how do you want to deal with it? Seek is what you'd think it would be. Seek makes it equivalent to map concurrently. Par on and par n just say like, so you give it 8, that means it's going to be doing at most 8 things at once. There's also extra patterns, which are cool pattern synonyms, which basically says, you might not know how many capabilities you have on that particular machine. Just say use all the ones you can find. That's what it does. This will not melt a hole through your disk. It will, of course, be, like you will definitely only be doing 8 things at once. So if you have 10,000 lookups to do, maybe 8 at a time, might also take a while, but no melting. So you decide. And like map concurrently, the order is preserved, so that's pretty handy. Should I talk about generic lens? It's 3. Shall I keep going?
Yeah.
You're the boss. I have to be here. OK? I guess this is cute. OK, so here's a common pattern for generating lenses. You've got your data type, and this make lenses thing is some template Haskell, which says if you prefixed the name of each of your fields with an underscore, it will generate the lenses of that same name, but without the underscore. So then you can do things like this. You can say, OK, so yeah, we got our cat data type here. Name, age, money. My cat's got a bank account. I don't know about you. He's terrible with money, though. So we've got Jack here, and he's 6, and we have him $10. And we can use a lens. So notice that like the actual lens there, the name lens is missing the underscore. That's what the generation gets you, and you can get out Jack. Say Jack's been a good boy, so we're going to give him some money. So now he's got $15. There's just using the operators to do like a set operation. OK, well, there's a way we can avoid the template Haskell if that's what you wanted. So notice that we took the underscores away, and we just named them we named the fields what we wanted to name them. And you might have worked on projects where the names of the fields were these gross things. They've got an underscore, then they've got like the name of the type. So it could be like the gross way to do this would be cat, or like underscore cat name, underscore cat age, underscore cat money, and you've got this giant field of all these field accessors. I don't like coding that way. I don't like characters. Like the point of coding is to stop coding, right? What generic lens lets us do is if all we do is derive generic, it generates lenses for us. You can do a lot with it, but all I'm showing here is how to access fields. So this is field at name. That's a type level list. If that is incorrect, like if that name is missing the E, it won't compile. And it'll say, hey, did you mean name, actually? It gives you fairly intelligible errors. And so you can do it the same way. What's up? A little bit? A little bit. It's actually fast for comp. Yeah. I think it speed, yes, basically. Like, because the template Haskell is gone, it can at least infer the types much faster, which is what you're looking for at the end of the day. Like when people say, oh, Haskell compiles slow, I say it doesn't matter, because if you have GHCID running, it's not doing any actual compilation anyway. You didn't need to compile to get your type information. Sometimes it can be. It's not that it's too slow. It's that if you had changed a module in which there was template Haskell, it will regenerate. It'll redo the code gen, which slows down your turnaround. So here's an interesting thing, is that we also get sane to JSON and from JSON instances this way. Had we also derived to JSON and from JSON, the JSON fields would have been the exact same thing. It would have said name, age, and money, and you wouldn't have had to have handwritten your instances to go from your gross field name to like the sane one. If you combine this with the duplicate record fields language pragma, then you could have as many data types as you want that all have the same names, and they all have sane JSON instances. I have a code base that's like this. It works well enough.
Have you also looked at overloaded labels?
Overloaded labels, I haven't.
Where you can basically replace field at name with hash name.
That would be fun. Strict tuple. OK, here's a quick one. So You want to speak to the powers that be. You are sending them a stream of questions, but the gods of Olympus are fickle, and they are not giving you straight answers. They're only giving you a tuple of a hint and a warning. Well, great, thanks. This actually causes a space leak. Do you know why? It's because the second element in a tuple is lazy. This will create a lot of thunks, and it will basically run your program out of memory. I know that because I've done it. Use strict tuple, which is exactly what it sounds like. And you notice that the syntax is basically barely different. You've got something like T2 through maybe T9 or 10. And I mean, if you've got tuples that big, you're probably doing something wrong anyway. T2 and T3 is basically as far as you ever need to go. But that will prevent the space leak. Strict data. So I don't think this one's controversial either. OK, so John DeGos has some workout. It's for some amount of time at some place, and he has particular workouts. Really, in 2019, I don't think there's a reason not to write the data type this way. If you want, you can put the strict data language pragma at the top. If you know that your thing is a primitive type, you can unpack it. What does that do? It means that it's no longer heap allocated. It certainly won't box it. It basically means that it's byte packed at that particular location. And if you've got, especially if you've got a million instances of John's workout, I don't know how often he works out, probably a lot. That saves you memory. Like if you've got some big application that's churning tons of data, using unpack like this wisely can save you significant amounts of data and GC time. Pardon me. This also helps reduce the strain on the strictness checker inside GHC while it's running. Sorry? I might be wrong. You might not need that, but recently I've been confused about when you need it and don't, depending on your compiler version. That may be true. That might be my mistake. Monad state. OK. These are just two sort of like perhaps little known operators that you can use in monad state. So we've got some environment that has a field called foo. It's the only one we care about. And just for right now, we're generating them via the lenses. And we have some function or via template Haskell. And we've got a function from foo to foo. So we can't just apply bar to env because the thing that we want to manipulate is inside of our environment. Well, OK, everyone's written this code. You're in some sort of state, and you're like, oh, I'll get it, and then I'll change it, and then use like record update syntax to do it, and then I'll put it back. OK, well, that's a lot of characters. Then later you learn, cool, reading the docs helps. There's this cool modify thing, which I can just use to sort of one-line it, in that it'll just give me the environment in one step. I can just change it, and the result of that will automatically be put back as the thing in your state. Well, guess what? That's much better. At least for me personally, I would want to write the last one. You might say like, oh, well, what does that even do? I'd say that that's an education problem. And if you're in an application and you're writing Haskell every day, that takes 10 seconds to learn what that does, and then it's forever learned. And whenever else you see it in the code base, especially when your boss wrote it and there's no chance to delete it, you will have success. What does that do? That is the lens. That's the function you want to use to manipulate it. That basically just says, jump into the state, use that lens to get the thing, use that thing to manipulate it, write it all back. 3 tokens. This is the last one for the main section. This just shows how we can use pockets of maybe t and except t to do things like I was saying that maybe having giant transformers aren't the coolest thing, but often at least combining maybe t and except t with I/O, you can get some nice little patterns that can get rid of some boilerplates. So we have an idea. We're going to make a Facebook killer. Mark Zuckerberg has no idea what's coming for him, right? So we have 2 functions. We have get friend and sell data. We sold our morals a long time ago. So first we get the friend. But getting the friend might not actually succeed. Well, then we pattern match on the result, and oh, darn, it didn't work. And if it did work, then we keep going. But then that also, you might have failed to sell the data because someone was like onto you. And then so you pattern match on that again, and OK, I guess Mark wins. And then, but if you finally got through all of that, then you can actually do your f, which is just some function that who cares what it does. We've all written that. We've all written pattern match ladders like this until we learned. First we learned about lambda case. Well, OK, we didn't have to actually repeat those names. Notice that mfriend and mfriend, as well as mdata and mdata, were only used in one place each. That's usually a sign that you never needed that symbol. The point of programming is to stop programming. So put your money where your mouth is, right? Get rid of the thing. You didn't need to use it. You can use lambda case to just go right into the pattern match, and you just never needed the symbol. OK, so we've shortened our thing down. There's still maybe some improvements that we can make, because we've still got 2 pattern matches. That's usually a bad sign. That's usually smell. OK, well, what if we just factor that out? we'll make it we'll pull out this G, which is sort of the calls. It's like the main sort of logic of it, and we'll put it in a maybe T. So we get friend, and we just wrap it in maybe T right away, and then we don't have to deal with the pattern matches because of the way that the transformers work. IO will basically always succeed unless it throws, and maybe T will sort of fail the whole thing. It'll fail the whole do if the maybe part of it was nothing. Okay, so pretty handy. So we get the friend, and we can just assume it's the actual thing, and it will be because that's how maybe T works. And then we can try to sell the data of our friend, sorry friend, and also wrap that in a maybe T. Then at the top, we just run a single maybe T, which is the equivalent of, it basically just says unwrap it all. So the result you get out of that is the IO maybe again. And you do have to do sort of one pattern match here. And you can get the final result. This might not look like much of a change because we only sort of took 2 pattern matches into like 2 lines, but you could see how this might save you if you had, say, 4 things you were attempting, or like 6 or whatever. In which case you'd have, instead of having 6, like a 6-level nested gross pattern match ladder, you only have 6 straight lines here, which are all nicely aligned. And you only have to do the 1 pattern match at the end. You might notice that these actually aren't equivalent because there's only 1 error message at the end. Whereas before, we had 2, 1 at each step. If the first one failed, we'd say no, and if the second one failed, we'll then mark wins. But in this case, we only have the 1. Okay, so we screwed up. Well, how can we get those messages back? We'll use except T instead. I'm also using the errors library. So we'll get a friend. If we couldn't do it, let's note it. We'll actually give the error message back. And the second one, okay, we tried to sell the data. We couldn't do it. The government was onto us. And we'll note that as well. The whole thing is now an except T. We'll do a single unwrap back at the end. Then we're just doing a single pattern match at the end. Left or right, print the error, or operate. I think that was, and if you had the I for the pattern, you could actually see that you didn't need the pattern match at all. You could use the either combinator to just get through it right away with a bind, and you've freed yourself of the bound names E and B. We can argue about how readable that is or how beautiful it is, but you can't argue that it spends less calories on your eyes. Was there a question?
Well, I just want to comment if you're at a good breaking point.
This is basically the end of the main thing.
Oh, okay. So the idea that non-empty containers is maybe a good thing, I can see the wisdom of that. When you said that, I thought of a lot of situations where that would be the right thing. But on the other side,
yeah, argue please.
Statement, if you do that, you're pushing the onus of checking for if then else to the caller, and pretty soon you have if then else, and it just keeps being nest off and the screen.
Right.
And some call sites will forget to do that or do the testing for empty containers in a different way, and then you get no reference errors. So having the callee know about it, what to do in the event of an empty container, good for 2 reasons. One is it's a definition. That's the callee's way of saying, hey, if this happens, we know it happened, don't worry about it, it's not an exceptional case. And the other thing is when you're changing piping, it makes it nice because you're going through the same pipeline, the container goes null, and then from that point on, the rest of the chain goes through as it normally would, except everything becomes null.
In this case, they're different data types altogether, so you don't need to be actively checking for emptiness or fullness. It's the non-empty container has something in it guaranteed. And my experience is that you basically only have to do the emptiness check in one place at the beginning. Sort of when you've pulled in your stuff from the outside, from the environment, maybe they gave you garbage inputs. You checked. Well, if they did, then you can just dump out right away. You never had to start anything. You didn't have to fire up your databases or whatever. You can just say, hey, your data's malformed. You can then force everything into the nice, pretty non-empty format, and you essentially live in non-empty land for the rest of your program. That's been my experience. What was the other thing? I think that was it. Yeah, just by construction, there doesn't need to be active checks. It's like you can't construe the type of a possibly empty list, like the normal one, and the non-empty version. Like they're different types altogether. So you couldn't pass a non-empty to a function that was expecting a normal function, unless you did a cast, but then you know you're doing a cast.
Let's wrap up in 3.
Yeah, well, we can wrap up in now. Thank you. I have more, I'll just breeze by them really quickly. So, use opt-parse generic. It'll save you more lines than having to write all your command line options yourself. You basically get command line options for free. Gabriel Gonzalez is smart. Principle of, what did I say here? Oh yeah, be aggressive about using new types. It will help you, it will prevent foot gun. Use lambda case. Yeah. Record wildcards, don't use those. It does code gen, it'll make your code slow, and it also is confusing to read. Like it pulls, you see the underscore planet field up there, and then you're using it down here as if it were like a piece of data that you bound to. It's hard to understand, don't do it. Be explicit about your exports and document them nicely. I believe it also improves compiler performance because there isn't such a giant search space for when you're like importing things. And also, here's a cool trick. In your main module, export your main explicitly. What does that do? It means that anything that you forgot to use in your main module will get flagged as being unused, because if you had wall on, that's one of the things that it'll tell you. And that's typically you won't have that. It'll just be module main where. And then you might have had some extra utility function that you forgot about. Maybe you did some refactoring and you didn't need it anymore, but you forgot to remove it. If you explicitly export main, it'll notice like, hey, dude, you didn't actually need anything else. And that's actually the end. Thank you again.